So hopefully now everything works well. I'm gonna leave it like this and I'm gonna start. It looks like it's working. I tested it on one level deeper as well. It looks like it's working. And I refactored or I changed the code for displaying the names there. Maybe I'll show this. And then I'm gonna write articles now. I wanna try to write 4 articles a day from this 20 so that I can finish in 5 days. And then I can start writing articles about other stuff. Its own categories. That's basically what I did. Since I'm not using this stuff anymore, I'm getting from the props. I put the post name as this to split the path and get the last item of the path, which is gonna be the name of the folder or the file. If it is a file, it's gonna have .mdx, so I got this thing here. If it's a folder, then it's just a name, and that looks like it's working. Hopefully it works for all of the possible levels in the future, but if it doesn't, then I'll figure out a way in the future to make it work. So now I'm going to focus on this article here, which is the just however you say this fucking thing here, and I wanna finish the 4 ones today. This looks like it's working. I'm gonna set a timer for 2 hours, and I'm gonna try to finish them in 2 hours. And if I can't finish them in 2 hours, I'm probably gonna finish them off stream because I wanna go for a run after these 2 hours. So I'm gonna separate half an hour for each one and then 2 hours. And I'm gonna use ChatGPT to do it. Okay, so first thing that I wanna... Oh, maybe I should watch the videos here from this guy teaching how to do... But I think and also I think I'm going to accept these terms here, terms of service for this app. I think what I'm gonna do is just not use that for when I'm doing prompts that are related to other stuff, but if not, then I'm gonna use this thing here. Yeah, so whatever. And this is the one that I used to create the 20. So I think I'm gonna read this stuff here. Prim's algorithm is an algorithm for finding a minimum spanning tree in a connected... I think I'm just gonna copy this stuff from ChatGPT. Fucking hell.
It starts with an arbitrary vertex as the root and growth.
We're just gonna copy this. And the formatting of this, it doesn't matter here. It does matter if the line is shorter than the maximum amount, the maximum limit. I talked about this on previous stream, that I would have to figure out how to make the structure the same, but then I realized that I changed some things on the layout on the page itself, and then it works. Oh, I also forgot to change... Oh, but... Yeah, actually, because I changed the categories component, I don't think I need to change the... Maybe, yeah, maybe I do, actually. So I'm gonna do that after. I need to copy this file here for the other ones. Because the other ones are still on the old way that is gonna break. The Prim's algorithm is a connected and directed graph. It starts with an arbitrary vertex as the root and grows the tree by adding the cheapest edge. I connect a vertex in the tree to a vertex not in the tree, until all vertices are in the tree. Popular method for finding the shortest path. Oh, this is Prim's algorithm. I'm gonna do this stuff again though. Damn, that's crazy. I think I'll start with this one. A post title generator. The hard part is gonna be understanding the code and seeing if the code is correct. The rest I think I'm gonna copy from ChatGPT. Didn't mean to vote that. I also think I'm gonna erase this thing here because it's already on the algorithms. The only thing is that I can't... Oh, I put here. And this one I think I understand already. Method for finding the shortest path between two nodes in a weighted graph. The algorithm starts at the source node and explores the shortest path to all the other nodes in the graph. It uses a priority queue to select the node with the smallest distance from the source node. So a priority queue is, I think, a tree structure. I don't remember really well. I know that the heap is a tree structure, and that in Python it's the default when you use the heap queue library is to have a min heap, which means that the smallest value is at the top. And that's very useful for our graphs, because for these types of algorithms, because it usually involves getting the smallest weight, and so the heap queue is very useful for that. Select the node with the smallest distance from the source node and updates the distance to all neighboring nodes. The algorithm continues until the destination. So what I'm gonna do is I'm gonna prompt ChatGPT and I'm gonna read the description, and then any questions that I have about, because I don't understand the topic myself really well. Obviously I understand the fundamentals now of programming, of data structures and algorithms, but I don't know the specific algorithms. And also these data structures here I don't understand really well. So what I'm going to do is ask any questions I have, and then I'm going to expand on the text based on those questions. And maybe synthesize to make the text smaller as well, I'm not really sure. Select the node with the smallest distance from the source node and updates the distance to all neighboring nodes. The algorithm continues until the destination node is reached for all nodes that have been visited. The algorithm guarantees that the shortest path is found, and it is widely used in routing protocols. So how does work? Priority is a data structure that organizes elements in order of priority. The element with the highest priority is typically at the front of the queue, while the element with the lowest priority is typically at the back. Elements can be added to the queue in any order, but when they are removed in order of priority. This can be achieved through different data structures like the heap, linked list, or array. In whatever you say this, our algorithm priority queue is used to keep track of the unvisited nodes, with the priority being the current distance from the source node. The algorithm repeatedly selects the node with the smallest distance from the source node and updates the distance. Show codes. For example, that uses the priority queue. I typed wrong here, but it doesn't matter, I think. Maybe we should just put the prompts here. Priority. Yeah. I'm not really sure if this is gonna be good enough to rank, like doing things like this, but I think it's based on the stuff that I was thinking about. I think it's the only thing to do, because that's how market dynamics work. Like, there's nothing you can do about it because of the arms race. People are gonna do this anyway. So, and if you don't do it, but then there's obviously the question of the trade-off there, where because everyone's gonna do this, it's gonna be a self-fulfilling prophecy. That is gonna become a vicious cycle because nobody's gonna be incentivized to create things anymore. But I think that it doesn't matter in the short term. It's better to have speed and then shift later, because people that are faster are probably gonna have the advantage, like in any other situation. And then by that time, then it doesn't matter if you are more authentic in the beginning, because you would lose for people that went fast and gained an advantage, and those people can just refactor later. That's usually what happens, I think, in whenever there's something like this happening. Priority queue is a data structure that organizes elements in order of priority. The element with the highest priority is typically at the front of the queue, while the element with the lowest priority is typically at the back. Elements can be added to the queue in any order, but when they are removed in order of priority. This can be achieved through different data structures. Data structure like heap. The other thing that can happen with this is that it becomes even more of a politics game than already is, because the only way that Google is going to have to differentiate different articles and different blogs and things like that is going to be through the politics structure, like the backlink structure. And that's even worse, because it becomes more of a vicious cycle then. It becomes more authoritarian than already is. A priority queue is used to keep track of the unvisited nodes, with the priority being the current distance from the source node. The algorithm repeatedly selects the node with the smallest distance from the source node and places the distance strips in neighboring nodes. Let's see if this one is the same or similar. So this is creating an object instead of a list of the float to infinity, then creates the first element equals to 0, which is going to be the distances, then priority queue, then pops this, making the vertex, which is the key, and the value is the vertex, which is the node. So the key is the distance, the vertex is the value, I think. Or other way around. Yeah, the other way around. The distance is no longer the current shortest, we're done. So current vertex is the start, and the start is given, which is the first node that is going to calculate the shortest path from. So the first node, and then you have 0 as the other one, which is the distance, the first distance. So this is gonna be 0 in the first iteration, and current distance is gonna be 0 as well. And then it's gonna loop through all of them and store the value in the flag variable to check which one of the neighbors has the smallest value, and then it's gonna put that inside of the distance thing using the index, I think. Yeah, current vertex is the nodes. Neighbors, wait. I think this is correct. Yeah, I think this is correct. So I'm gonna put there. So this one I got from the other source, but and also I think I'm only gonna do Python because doing the other languages is gonna take a lot of time to figure out, because I know that you can use something with Prisma, I think, that I was gonna look whatever this is, to add a bunch of different styles, a bunch of different languages to the code block. But then it's gonna take more time to figure that out, and I don't wanna do that right now. Maybe I'll do it in the future. Then I'll delete the rest of this stuff here. And maybe this is too short, but I don't think it matters that much. I think it's better if it's short. But one thing that I don't like when I go into these blogs is that they usually have a bunch of stuff that doesn't matter, just to make the article longer. I don't think that's good. It keeps people longer on the thing, I think, for each article, but it doesn't, long term, I think it hurts more, because then like the person is not gonna want to they want to go straight to the, I think it's better to put the thing that they are searching for first, and then put the other version that is longer later with a deeper explanation. Maybe I should put a link to this one instead of this. That might be a good idea. I think I'm gonna do that. I think you can do it like this. Yeah, but here is the thing that I don't know. Maybe I just put the relative path. Algorithms. Routes. 20. That's routes. MVS. Let's see if this works. It doesn't, because I'm going from the path that I have now, so I could just put algorithms here and it's gonna work. Hopefully. So I remove this thing here. Yeah, there we go. I think I also need to make these letters bigger. I'm probably gonna do that at some point. Also, I wanna test if the natural reader works. works. Nice.
The algorithm continues until the destination node.
Dijkstra algorithm is a method for finding the shortest path between two nodes in a weighted graph. The algorithm starts at the source node and explores the shortest path to all other nodes in the graph. Use a priority queue to select the node with the smallest distance from the source node and updates the distance to all neighboring nodes. The algorithm continues until the destination node is reached or all nodes have been visited. The algorithm guarantees that the shortest path is found and is widely used in routing protocols, network design, and many other graph-related problems. Priority queue is a data structure that organizes elements in order of priority. The element with the highest priority is typically at the front of the queue, while the element with the lowest priority is typically at the back. Elements can be added to the queue in any order, but when they are removed in order of priority. This can be achieved through different data structures like heap, linked list, or array. In Dijkstra algorithm, a priority queue is used to keep track of the unvisited nodes, with the priority being the current distance from the source node. The algorithm, let me read that again. A priority queue is used to keep track of the unvisited nodes, with the priority being the current distance from the source nodes. I think I got it. The algorithm repeatedly selects the node with the smallest distance from the source node and updates the distance to its neighboring nodes. So I use this here. And then there's a heap pop, which is gonna take the smallest value from the priority queue, I think. So if the distance in the queue is not the shortest, we're done. The current one, because it means that you got the smallest value from the heap, I think, based on the neighbors. Current distance plus weight. Current distance plus weight. Where's the weight here? Oh, it's here. Yeah, so weight is the current vertex. No, it's the value there. The value of the node inside of the object. Makes sense. And because it's the nested object here, then the keys are gonna be the nodes, the neighbors. Maybe, I'm not sure if I understand really well, to be honest. I understand the algorithm, but this code, I'm not really sure. I'm gonna spend some more time. I think after I understand this, I'm gonna move to the next one. I probably have a lot of time left still. I still have 7 minutes for this one. For neighbor weight in graph current vertex. Which is the start node. Yeah, I'm confusing the distance thing here with the graph. That's why. So this gets the current node from the graph, which is going to be this object, and then it's going to get the items. So now it makes sense. So it's the weight and the value is the weight of the neighbor, and the key is the neighbor. And that makes sense. So the distance is going to be equal to the current distance, which is this thing here, which is 0 initially, because it's the same node. The first one is the start node, so the distance is 0. and then it adds the weight of the neighbor to that, and that becomes the distance. And then it maps out to the other dictionary with the key of the neighbor and checks to see if that distance is greater than the current distance, and it's going to be on the first one because it's infinity. And then it replaces, if it is, it replaces the distance. So it's pretty much the same pattern. It uses the flag variable and then replaces the distance and then pushes through the queue. This part here is kind of confusing for me because I don't understand really well. So maybe I'll ask how this heap, the heap, build not heap push part works. And I think because I understand a little bit about the fundamentals of data structures and algorithms and how it works on the more macro perspective, let's say. Like I might not know exactly how this method works, but I can deduce if there's a high chance that is incorrect or correct based on first principles. The response, I don't think I need to search for to validate on Google, because I can just use the logic that I already have and then deduce from first principles if there's a high chance that this is incorrect or not. And I think this is correlated with how much you know, because the thing is that the difference between searching on Google and just knowing stuff is that just the amount of data you know, because I think human beings learn in the same way, where we update data from the environment into our biology. So that's why it takes time to learn, because you're downloading the data into your subconscious, which is the structure of your body. So all it means for you to know something very well, it means that you spend a lot of time downloading data from whatever place and integrating the data with the logic that exists in the geometry of your body, which are your synapses, and then that makes you understand something. That's what we mean by understanding. So when someone is good at something, it just means that they downloaded a bunch of data and fit the data based on the geometrical logic of their biochemistry. So this is the use of ChatGPT, I think, is correlated with this, because you're able to synchronize the data with yourself depending on the gradient of how much data you have about the topic in your subconscious. And there is this direct relationship. If you have low data, then it means that it's higher risk because there's more volatility. You have to trust more on the response. But if you have more data, then you can deduce from first principles because you have high density of information that makes it so that you can increase your efficiency in parsing the response through first principles. The ripqueue.rippush function is used to insert an element into a priority queue heap in Python. A heap is a specific kind of data structure that maintains the heap property, which states that the parent of any element in the heap should be less than or equal to its children. If give heap push heap item as the given item should the heap represented by the least heap. The function internally rearranges the elements of the heap to maintain the heap priority after the insertion. Okay, so it's adding the priority queue, which is this thing here, with the distance and the neighbor. So it's updating these true values here with this true here. It makes sense because you want to move from neighbor to neighbor and you want to increase the value of the weight with the current distance. So you're pretty much caching the distance with a flag variable, and then you're updating that through the loop by using the queue, which is the data structure that is optimized for that. And you use the library because the library has some algorithms that is going to run in order to make sure that the heap structure is maintained after the insertion. I think I understand, and I think this response is probably correct. The time complexity of this operation is O log n, where n is the number of elements in the heap. So maybe I should put this stuff here on there as well. Is used to insert new elements in priority each element, blah blah blah. So I'm gonna put here Fuck. Yeah, now I'm gonna check here, and if it's was fine, I'm gonna move on to the next one. In this example, the heap queue, heap push function is used to insert an element into a priority queue heap in Python. A heap is a specific kind of data structure that maintains the heap property, which states that the parent of any element in the heap should be less than or equal to its children. Heap queue.heap push heap item adds the given item to the heap, represented by the least heap. The function internally rearranges the elements of the heap to maintain the heap priority after the insertion. Time complexity of this operation is O log n, where n is the number of elements in the heap. Yeah, so it keeps increasing the heap, but because the heap organizes things such that the lower element is always the first to be removed through the heap pop, it works to see, it's efficient to see if it is the smallest still. I think I understand. So this is correct. I'm gonna move on to the next one. So the next one I think is Prim's algorithm. Prim's. I'm gonna add this stuff here. Close this one. And now I'm gonna have to reload this thing so I get this thing here. That's better my description. I'm gonna do things like this. And then I'll go back to the other one. The other chat to continue asking. Maybe I should do all of these on the same prompt as well. Maybe I'll check to see if there's a better way to also. But the problem is if I go here, it's not gonna give me this thing here. Create a keywords strategy and SEO content plan from one word. Find the best place and anchor. Outrank the competition with an in-depth SEO optimized article based on your competitor. You all be like your competition. Smart and detailed article writer. Give the title of the article you want written. He tries to write long and detailed article. It makes it ready for sharing with page tags. You know, the other thing that I have to see is if I'm gonna make I probably should make a table of contents as well, because I think that's helpful. So this one is probably one I can use, and this one as well. I think I'm gonna use this one first. I got the title first, I already got the SERPed, and then I'm gonna change this stuff here. Okay, sequence, Spain tree Africans there. I think this one is probably the best. Yeah, the only thing is that I couldn't find a way to remove this thing here. So what I'm gonna do is put this here. That's what I did on the previous one. Because if you use backslash, it doesn't work for this metadata. I think it's something to do with the way that the front matter works, but I'm not really sure. Prim's algorithm helps you find the minimum spend tree, blah blah blah. Prim's algorithm, the key to solving complex graph problems. For optimizing your code. CPs. I think that's this minimum spending tree. I think that's good enough. I'm gonna search for. I'm gonna start the timer for half an hour. If I can't do it in 2 hours, it's still obviously really good. But I wanna try to finish in 2 hours, so maybe I can do more today. The thing that is obviously gonna be slower is the understanding how to use this thing here. Martin Day article writer. Yeah, I think it's this one. Then I got the word that I got there from the other one. Damn, this is really good. The only issue is that the internet's gonna be flooded with this stuff. That's why I think almost for sure I'm gonna have to refactor all the articles at some point. I'm already expecting that. And I'm also thinking about doing another website that is gonna be the clone of this for Portuguese. Because I'm Brazilian, so I understand Portuguese and I can do both at the same time. In Portuguese should be easier, I think, because there's less competition. And I can translate all the code. But the issue with that is that I'm gonna have to look for affiliates in Brazil, and it's gonna take a lot more time, so I think I'm gonna leave that for the future. Once it gets to the point where I think it's gonna be a good idea to refactor a bunch of articles, then I think I'm gonna do that probably. Because when I translate the articles to Portuguese, I'm gonna think about ways to refactor as well. But for some of this stuff, I'm not really sure anyway, because like there's only so much ways you can talk about something. So that's the thing that is, I don't know. I think the only form of innovation is going to be to add a bunch of different things that are not related. It's not going to be these kind of articles here, because it's going to be hard to find different angles to write about the same thing that everyone is probably going to use ChatGPT to write about. So yeah, this is ridiculously good because it gives the whole thing already. I don't need to do anything. Just copy this stuff. Yeah, the only thing I have to do is to make sure that it's correct, but it's obviously gonna write a lot better than I can write. Because it has all the knowledge from everyone. And this is what is weird about it, because it's kind of strange to think about this, but if you use ChatGPT data to, or the responses to write articles, it might be flagged as copyrighted, but it is not flagged if they use, like, the fact that they use all the data as well themselves to create the algorithm in the first place. It doesn't make any sense. Like, the only reason why ChatGPT and all these algorithms work and exist is because they can use all the data of the internet. And then you can say like that people consent to it, but it's kind of dumb to that kind of argument, because it doesn't make sense. You're forced by the rules of the game to comply. So like, it's a fake option. Banks do that a lot too. It's very annoying. Like, they force you to accept, to allow them to have permission over your, to have access to your microphone in the cell phone, smartphone. Otherwise, you can't access the thing, the updates. Really stupid. I don't understand how this is legal. It's like so dumb. You're pretty much forced to give all your data away to be part of society. And then they use all of that to create these artificial intelligence machines and to get all the data from everyone, to control everyone. It's pretty crazy to think about. But again, this is one of those things that is just a byproduct of the market economy because of the arms race. There's not, everyone's forced into this position because no one can think about a better system to implement that is not going to force everyone to in this position. I should probably put, I think it's like this, to make a list thing. I'm gonna check to see if this is correct or not. Should do like this. and doesn't work. I think it's like this then. Let's see if this works. So how do I do that? Oh, it has to have a space. And now it should work. I need to figure out how to format this though. I think I will create a component later. For now I'm gonna leave it like this. You can just create a component on the app there to solve it. So put here diddly and then whatever style I want, I think. I'll do that later. Yeah, it looks good. So now I'm gonna tell to explain.
There must be something in the water, 'cause every day it's getting colder.
Then after I get the article, the code, I'm gonna read and see if it's correct. I watched a couple of videos about the Prim algorithm, but I'm not 100% sure that I know really well. And the thing that I don't like about the videos that I find about these kind of algorithms is that it's not, they don't talk, they explain the algorithm first and they don't explain it showing the code. And I don't learn really well that way. I learn better if they show the code and then they explain on the code what's happening with visualizations of what's going on in the code. And so I'm gonna have to do this one in another prompt, I think, because otherwise it's gonna get from the history and then it's gonna mess up the sequence. So I'm gonna go here. I think I'll delete this one. And this is the one. And then I will get the code from this history here. It's 17 minutes. For later in the rectangle, the algorithm starts with an arbitrary vertex called the starting vertex, and then the closest vertex to the starting vertex to the MST. Then it continues to add the closest vertex that is not already in the MST until all vertices are included in the MST. The algorithm, yeah, let me see if it's explained what a minimum spanning tree is. I understand the minimum spanning tree. Prim's algorithm is a widely used method for finding the minimum spanning tree MST of a weighted connected graph, developed by Robert Prim in the late 50s. The algorithm, maybe I should go back in this one and do the same thing, because it's probably going to be better than what I did there. In this article, we will discuss the basic principles of Prim's algorithm, its implementation and complexity, and some of its key applications. By the end of this article, readers will have a strong understanding of Prim's algorithm and its potential to solve real-world problems. Through this, understanding the minimum spanning tree. Before diving into Prim's algorithm, it is important to understand what a minimum spanning tree is and why it is useful. The spanning tree of a graph is a tree that includes all the vertices of the graph with a minimum number of edges. The weight of a spanning tree is the sum of the weights of its edges. A minimum spanning tree, MST, is a spanning tree with the maximum possible weight. With minimum possible weight. Finding the MST of a graph can be useful in a variety of situations. For example, in telecommunications, the MST can be used to find the most cost-effective way to connect a set of cities with telephone lines. Transportation, the MST can be used to find the most efficient route for a trucking company to take between a set of cities. Networking, the MST can be used to find the most reliable way to connect a set of computers in a network. Use algorithms, a greedy algorithm that is used to find the MST of a way to connect a graph. The algorithm starts with an arbitrary vertex. At each step, it adds the next closest vertex to the current tree. The algorithm continues until all vertices have been included in the tree. The basic steps of Prim's algorithm are as follows. Start with an arbitrary vertex at the vertex of the tree. Add the vertex with the smallest weight that is connected to the current tree to the tree. Repeat step 2 until all vertices have been included in the tree. One of the key features of Prim's algorithm is the greedy algorithm, this method. This means that it makes locally optimal choices at each step without considering the global consequences. While this can sometimes lead to suboptimal solutions, it also makes the algorithm relatively simple to implement and understand. Yeah, this is the thing that I was talking about though, that I don't really like this kind of articles because it talks about a bunch of different stuff, and yeah, but maybe I think this is better for SEO though. That's probably the reason why people do it like this. I think as long as I put the code there at the end, it doesn't matter that much. I think this is the same one that I used on the other article. Yeah. And it does make sense. I understand better now how it works. I think this one is a simple one. And this example is different than the other one, but wait till you here. I'm just gonna copy this stuff and then put there, and then I'm gonna put the explanation after. And like I said before, I'm just seeing what happens if I do it like this. I assume that I'm probably gonna have to change it at some point and to refactor everything. But I think speed is more important than to worry about this now. And then we'll see what happens. This function takes in a graph represented as an adjacency list and starts a starting vertex. and returns a set containing the vertices of the MST. The heap queue library is used to implement the priority queue, where the priority is the weight of the edge. The algorithm starts by initializing an empty MST and adding the starting vertex to it, and adding all edges adjacent to the starting vertex to the priority queue. The while loop continues until the priority queue is empty. In each iteration, the edge with the smallest weight is extracted from the priority queue and the vertices of the edge are added to the MST if they are not already in the MST. And all edges adjacent to the new vertex are added to the priority queue. Seems like it is correct. Let's see how much time I have left. 10 minutes. Conclusion. It's powerful and widely used math for planning. Yeah, so this is the minimum spending tree. And it has the 2 first nodes. In the beginning is going to be the start node, then the weight is the value. It's very similar to the Dijkstra or whatever, however you say that thing. And I think I'm gonna do that now. I'm going to go into the other article and I'm gonna remake the other article. And I think I'm gonna leave this one as it is there. At the title. The other thing that I'm thinking about, but I think I'm gonna look more into this after I have a couple of articles, but I'm gonna try to incorporate this print on demand thing. I'm going to create a tab on the navigation bar of merge, and then I'm gonna find one of the sites, one that has best offers and highest quality, the most cost-effective one. But obviously to do that I'm gonna have to do research, and it's kind of annoying to do research on these kinds of things because there's a bunch of people trying to sell a bunch of shit and they hype things up and it's not true, so you have to parse through all the bullshit to figure out which ones are the best. And then after I find the print of demand thing, I'm gonna put the merge on the sites, and I'm also thinking about different ways where I can incorporate Web3 to make the thing profitable, because I think with just affiliate marketing is not a very good strategy, because I think the conversion rate's pretty much always going to be very close to the same regardless of what you do, because it's one of those things that is probably grounded into the laws of physics in the same way that Pareto distribution is grounded, I think, in the reproduction pattern of behavior. I think the conversions are pretty much the same thing because it's dependent on the system, and the system of funnels is usually going to convert around 2%. So for the amount of people you get to convert 2% usually, and obviously you can have outliers, but you can't rely on that. So usually it can be less as well, so around 0.5 to 1%. So taking that into account, the only thing you can do is increase the amount of profit you make from those conversions, and that's from the long time customer value that you get by creating email lists and things like that. Creating a product, because if you have the product, obviously you're gonna keep a more percentage of the profit for you. To do affiliate marketing, most of the profit is gonna be for the owner of the product. Amazon is good because it allows me to do it. I don't have to. Most of the sites is hard to get accepted, but the downside is that the offers are not very good, I think, the percentages. So I was calculating, and to get a decent amount, I think you need to have a lot of traffic, which is very hard to do. This time I'm gonna do one by one because I think it's easier to convert there. I'll do it like this. So, but the challenge is to think about something that I can do with Web3 and incorporate in the blog. I think I'm gonna use ChatGPT for that as well, for ideas. And the code, I'm pretty sure I can do it because I built smart contracts already. I understand how it works, and I'm probably gonna make articles about smart contracts as well, and about consensus protocols and proof of stake and cryptographic things like zero knowledge proof. And through that process, I'm gonna learn more as well. I think I'm mainly interested in learning about design patterns in Solidity because I'm not very good at that. I know about the proxy pattern and the other diamond proxy pattern and something like that, but I have to look more into that. No, but the issue with creating the product is that there are so many products out there already. So I think it has to be something that is niche and also relatively easy to do and to start in the beginning. So it's going to be hard to think about what to do exactly. And probably I will have to do a bunch of different things until I find one that works. And I think ChatGPT does these things with Markdown as well. I realized later the table is probably done with Markdown as well. So that's probably what they're doing to create this extension that allows you to do these things. They probably created some database that has some prompts, some template with prompts, and then they just change. It's probably a string and they just change the variables there, depending on your inputs. And then there's probably something you can do to tell ChatGPT to use Markdown to create things. But I don't want to do something related to this because I don't think it makes sense to what I'm doing. The only thing that I thought about involving AI would be to create something related with Midjourney and ChatGPT and NFTs and things like that. But I couldn't think about something good that it's not gonna be extremely hard in the beginning, and that allows me to integrate these things to create something that makes sense to put on a blog website. I think this is one I'm gonna leave because it's related to the algorithm. Maybe I should put the conclusion after. Makes more sense. I think this is fine, probably. So I think I'm gonna go to the next one. It's almost time. So the next one is Kruskal's algorithm. I'm gonna get the title first. Title, then I get the inherit thing there. The excerpt thing. Oh, I forgot to copy the code. Don't forget I erased the code by mistake. The code part here. Yeah, I don't want to do something with this step by step because or titles like this because I don't know what the output of the blog article is gonna be. I think this one is the best. It's like generic, but good enough. I'm probably gonna put, like I did on the other one, put the thing here. Yeah, but this I'm not sure if it looks really good as well. Maybe this one is better. Then I forgot how I did the excerpt, or however you say that. Best meta description, I think. Down. So maybe I have to just look for another way. Interesting. What if I do like this? Oh, but I don't think I use the prompt there. Ah, this is the prompts. Interesting. Ah, interesting. I also decided to leave the resources for, I think I'm gonna put that on that file. the resources for the blog posts in another folder to not put too many files in the project, because then I have more space to put blog articles. Don't wanna crowd the stuff too much. I think now it's gonna give me something because I'm putting on strings. But it's kind of weird that it said that thing. I guess I guess you can invoke some algorithms by doing a prompt with them or something like that. Like ChatGPT uses the algorithm to solve something, maybe. Because otherwise, why would it give me that error message? Yeah, now let's go for the article. I think it's better to just put the article first and not get the title. Just get the article and then think about the excerpt or whatever, however you say this, later. Because the title already comes with the article already comes with the title, so it's kind of dumb too. Yeah, but I'm using the title to get the article, but then I think I can just put the name of the algorithm. It's gonna give me like a good title. I think that the title thing is more when you don't know what you're gonna write about, and then you want to select a title based on the topic, and then you use the title. But I think for my case, it doesn't make a lot of sense to use that. Probably better to just use the article right away. And now I have to check if he's gonna output code. I think it is because it doesn't have a return statement here. I'll spend some time understanding this later.
What's that thing called when you meet somebody and you feel like you're walking on a cloud?
Yeah, sometimes it does this because now
Every step you made,
it was supposed to close the code block, but then
this place right here,
it stopped the output so that it switches things up
you know,
after.
it's like when you were at work and you said to yourself,
It's interesting that now I can see
I'm gonna go out.
though
So you put on your favorite
the
shoes,
tags that it's using.
put on your favorite jeans, and you get into the mood. You pull up to the club. It's a long line, but you don't care because you can hear the don't outside those doors. And you get that feeling all over again, and you get that chill up your spine because the DJ is playing your favorite songs back to back, and you're not in yet, but soon you know you're gonna be. Oh man, what's that feeling called again? What's that feeling called when finally you're in and you're standing in the middle of the floor and you open your arms real wide to accept those vibes, all those positive vibes, and your family's there, and all those people that are experiencing the same thing that you are experiencing at that moment in time.
Let's see how it looks. Let's see how much time I have. 19 minutes. Actually, just 11 because I took more time on the other ones, but whatever. Comprehensive guide to understanding and implementing the algorithm. Kruskal's algorithm is a popular algorithm for finding the minimum spanning tree of a graph. Greedy algorithm, range of solutions, network image segmentation. The minimum spanning tree of a graph is a tree that spans all the vertices of the graph and has the minimum possible total edge weight. But yeah, the downside of doing things the way that I did here, like I had to change the link from the markdown so that I put a different style because the default style is really bad. But the downside is that now the H1 and H2 tags are all the same. Like, I don't know, I couldn't think about a way to make it different because I'm using this thing here from this rehype library to make the links. So when you click on this thing, it puts the hashtag here, so that if someone shares this, it's gonna go to this point of the page. And you can do this with this rehype thing, which is one of this thing here, auto link. But then the problem is that I can't really change the style because I changed the default link and they are gonna have this thing here. So unless I create another, I guess I can create an H2 component and something like that, and then instead of writing things like this, I put the component. That's one of alternative I can do. But then obviously it takes a lot more work. It's kind of annoying. So I think I'm gonna leave it like this until... I don't think it makes them that big of a difference. That's but maybe in the future I'll create a component should change. The minimum spanning tree is a tree that spans all the vertices of the graph, has the minimum possible total edge weight. Kruskal's algorithm is used to find the minimum spanning tree of a graph by iteratively selecting the edges of the lowest weight and adding them to the tree until all the vertices are spanned. The algorithm starts by sorting the edges of the graph in increasing order of their weight. Then it iterates through the edges, adding each edge to the tree if it does not form a cycle. If the edge forms a cycle, the edge is discarded and the next edge is considered. Also, its vertices and tree is complete. Implementing Kruskal's algorithm. Kruskal's algorithm can be implemented using various data structures, including arrays, lists, and sets. The most common data structure used for implementing Kruskal's algorithm is the disjoint set data structure, also known as a union-defined data structure. This joint set data structure is used to keep track of the connected components of the graph. Each vertex is initially in its own set, and as the algorithm proceeds, the sets are merged as the edges are added to the tree. The disjoint set data structure is used to efficiently check if an edge forms a cycle by checking if the vertices of the edge belong to the same set. Checking if the vertices of the edge belong to the same set. I'm gonna have to spend time on this one. We're gonna search for this further. It's important to know that the above implementation uses an adjacency list representation of the graph, but the algorithm can also be implemented using an adjacency matrix representation. And the indentation is wrong here. It's the part of the code that got chopped up there. I think this set should be inside of the while loop, I think. But the return hash should be outside. So what I'm gonna do for this one is to open a new chat and then tell me to explain. I should put with code there. And then I'm just gonna use the codes from this prompt instead of the other one. Then later on, obviously, I'm gonna search for this, make sure it's correct. I wanna ask about the union thing as well. Should I clarify it a little bit more? This thing here. So it gets the vertices and the edges, then sorts the edges. Range tree. Then appends the nodes. Append the nodes to the parents. Rank it up and 0. And so is the weight, the vertices, and what is U? think this sat should be inside here. And then this should. Yeah, this makes more sense for me. And then this should be here. I think now it's correct. Yeah. It's pretty much the same thing. I think I'll worry about this. I'll check this stuff more later, but I want to finish 4 in 2 hours. These 4 graphs, so I can go run. Then after I come back, I'll probably off stream. I think I'm gonna watch some videos about this, and I'm also gonna look at other code to check if it makes sense or not. But I think from the brief look I gave here, I think it does make sense. I think it's correct. This code here. But obviously, it's a lot better if I spend more time making sure that it is correct. I think that's what I'm gonna do for all of them, and as long as I have access to ChatGPT, I wanna make as much articles as possible. So I'm gonna pretty much do like this. I'm gonna let it take care of the explanations, and then I'm gonna use just logic and first principles to know or to see if there's high probability that the stuff that is saying is correct, and then in the stuff that I'm not really sure, just based on my intuition, then I can search on Google or DuckDuckGo and watch videos to verify. Is that correct? Let's see. I want to leave it like this. New operation refers to the merging of two disjoint sets into a single set. What is disjoint sets? The union operation takes two sets as input and returns a new set that contains all elements from both input sets. In the context of Kruskal's algorithm, the union operation is used to merge the subsets of the vertices of the graph that are connected by the edge, being considered at each step of the algorithm. In Kruskal's algorithm, the union operation is used to check whether adding an edge will create a cycle or not. The union operation is used by define and union functions in the Kruskal's algorithm code. The find function is used to determine which subset a particular vertex belongs to, and the union function is used to merge the subsets of the vertices connected by the edge being considered. The union operation is typically implemented as part of a data structure called a disjoint set data structure, which is used to keep track of the subsets of the vertices in the graph. Here's a set data structure. So yeah, I understand it's used just to check for cycles, but I don't understand really well how it works. I search recursively until the parent I equals to I. Yeah, this one is difficult to understand. I'm gonna spend more time on this one. The joint set, also known as a partition or a union-find data structure, is a data structure that keeps track of a set of elements partitioned into a number of disjoint, non-overlapping subsets. Each subset is identified by a unique representative element called the leader or the root, and the elements in the subset are connected to the leader through a chain of links. There's a structure that keeps track of sets of elements, partitioned into a number of disjoint, non-overlapping subsets. Each subset is identified by a unique representative element called the leader of the root. The disjoint set data structure supports two main operations: find and union. The find operation takes an element as input and returns the leader of the subset to which the element belongs. The union operation takes two elements as input and merges the subset to which they belong into a single subset, with one of the leaders being chosen as the leader of the new subset. So it merges the two sets with only one leader. Disjoint sets are commonly used in algorithms that require keeping track of a partition of a set into disjoint subsets, such as Kruskal's algorithm for finding the minimum spanning tree of a graph, and the Tarjan's algorithm for finding strongly connected components in a directed graph. The time complexity of the basic operations in a disjoint set is O(n). The worst case, but using techniques like path compression in union by rank can make it O alpha n, where alpha n is the inverse Ackermann function and is greater than 5 for any practical value of n. In the case of Kruskal's algorithm, the disjoint set data structure is used to keep track of the connected components of the graph as the edges are added to the minimum spanning tree. The find operation is used to check whether adding an edge would create a cycle, and the union operation is used to merge the connected components of the vertices connected by the edge. Okay, I'll leave this stuff for later. I'm gonna move on to the other one. I think I roughly understand, like in general, but obviously it's better to look more into it. But I'm gonna do this off stream. I'm gonna try to finish the other one with the remaining time, which I think is Bellman-Ford. Oh yeah, you should. Got this stuff here. Some of them are probably going to spend a lot more time because they're more difficult to understand, and then others I can go really fast because they're easier. It probably follows the Pareto distribution rule, I think, where 20% are really hard, 80% easy, or the other way around. Because I think most of them are probably going to be similar, because they achieve the same thing but in slightly different ways. Fuck. Yeah, so probably gonna have to stop then. 33. Yeah, they're putting these limits because there's a bunch of people using it probably, and you can't really blame them because it's just gonna scale exponentially. I think more and more people using, and that's probably why I think that very soon they're gonna start charging, and they're gonna make. I think it's most likely that they're gonna make something like Midjourney does, where they have multiple different plans. But the issue is if they make a plan based on how many. I don't like the kind of plans that are based on how many lines or how many words you put, because it's very difficult to predict how much you're gonna spend. So hopefully they have a monthly payment or something like that. But also seeing that it doesn't cost too much to make this, to run this, so I'm not really sure how much they're gonna decide to charge for this. And that's the reason why I'm trying to do this as fast as possible. As many articles as possible, because it's unpredictable how much they're gonna charge. It might be too expensive for me, so it's better to have just a bunch of lower mid quality articles based on ChatGPT that I can refactor later. Once they start charging, then to just focus on having one good article, I think. And if I'm capped like this too much, then obviously I'm gonna do my research and I'm gonna use the articles that I already have to serve as a template of how to write the other articles, which I don't think is gonna be that hard, to be honest. But the only problem is that obviously I don't have the whole intelligence of the collective consciousness in the internet with all this data to know what's gonna be the best way to write to increase SEO, to optimize SEO. So even if it's not that hard to do, that's the issue, because it's gonna take a lot of experience to learn how to write it in a way that is good for SEO. But I think what I'm gonna do is get this. I'm gonna probably in a few more articles I'm gonna have a decent idea of the general structure, and then I'm gonna try to follow the structure as much as possible and just like use the titles as inspiration and just search DuckDuckGo or Google for the answers for the H2 tags here. Yeah, so here there's intro, what it is, how it works, application, then the codes, then the conclusion. Yeah. So I think I'm gonna stop here because there's nothing I can do, I think, for this. I might come back later and continue to do this, but I think I'm probably gonna do it that off stream. I think I'm gonna play poker today only, and I'm gonna leave it like this. Maybe I'll finish this Bellman-Ford. I'm definitely gonna study the Kruskal one because I wanna make sure that it's correct. So that's one thing that I'm gonna do off stream, but after that, I think I'm gonna finish the Bellman-Ford one as well off stream, and then I'm gonna play poker. I'm not gonna do any more articles today. So I'll probably come back tomorrow and continue to do these articles from that point, which means that there are still 16 articles left. So for the graph parts, and I'm gonna try to make more than 4 a day. Let's see. Yeah. Because after the next 4, I'm gonna have more data that I can go off to write on my own without using ChatGPT and be capped by this rate limit. So, and I think I'm gonna aim for 6 a day or something like that, and then I'll think about probably after the graph algorithms, I'm gonna go into another branch of the algorithms. Backtracking or tree. I think the next one I'm probably gonna do is tree structures, because those are the ones that I'm most interested about at the moment, graphs and trees. And then after that, then I can do the other topics as well. And I'm gonna finish these ones first, and then what I'm probably gonna do is to go to blockchain or to write articles on the other categories, so I have at least one article for each category. I think that's a good idea. So yeah, but I'm probably